Hello friends. Today's lesson is about introduction to linked list. In this lesson, we will talk about what are linked lists and what are different types of linked lists that is available. So linked list is a special type of data structure which generally used to store collections of data or collections of nodes. All the elements in a linked list are actually connected. So now that the elements are connected, so how a node in a linked list is defined? So every node in a linked list is defined by two parts. Okay. The first part holds the data and the second part holds a pointer to the next node. Think like we have to store a data 8, 7, 5, 6 to a linked list. Now for a linked list, all the elements needs to be connected. Okay. So we need to create 4 nodes. I'll create another node. It will also have element to store data and a pointer to the next node. Then I will create another node and then I'll create another node. Okay. Now the first node I will insert 8. The second node I will insert 7. The third node I'll insert 5 and the last node I will insert 6. And for the first node, the pointer should point to my second node, and for the second node 7, the pointer to should point to node 5. Similarly, for the third node 5, pointer should point to node 6. And if it is the last element should always point to null. This is nothing but this is a linked list representation of storing this data. The next question is, for storing linear set of data, we already have arrays. So we already have array. So inside the array, I can hold these datas 8, 7, 5, and 6. So now that already we have arrays with us, then why do we need linked list? The reason why we need linked list is arrays are constant in size. So whenever we are declaring an array, we have to specify the size of the array. So they are always constant in size. Okay. Let's say we have a requirement to add element dynamically or in the runtime, we have to increase the size of the array. So that will not be possible in case of array. This is where the linked list will come to the picture, where the linked list size can grow or shrink during the execution of a program. Okay. It is not like all the advantages are there by using the linked list. So linked list also has some disadvantages. Demerits of using linked list rather than using an array is, so in case of array, if I am trying to access the element 5, so array is an index based data structure. I can go to array of 2 and that will give me back the element that is present at index 2. But in case of linked list, if I want to access 5, I need to traverse through the entire element or entire set of data till I reach 5. So for array, the time complexity for accessing the data is big O of 1. While in case of linked list, okay, so in case of linked list, time complexity for accessing any data would be big O of n. To summarize, linked list actually does not waste memory. We can allocate memory at the runtime, but in case of arrays, we'll have to allocate memory at the time when we declare the array. Now let's look at what are different types of linked list. Linked lists are of generally three types. Single linked list. The second one is double linked list. And the third one is circular linked list. The one what we have discussed over here, so that is an example of single linked list. So in case of double linked list, let's say now we have to store this set of data 8, 7, 5 and 6 in a double linked list. So the linked list, every node holds a pointer to its next node as well as to its previous node. Okay, so now in case of double linked list, my node looks like this is my data. Okay, and this will be my pointer to previous node, and this will be my pointer to next node. Okay, so now we have 4 elements, so I'll create 4 nodes. So this is my second node, and let's say this is my third node, and let's say my fourth node I'll create over here. Okay, so for the second node, this is my previous, this is my next, this is my third node, this is my fourth node. All right, so now I need to insert 8 to the double linked list. So I insert 8 at the data position. Now the previous node, if it is the first node what we are inserting, the previous node should always point to null. Okay, now the next node point to the next element. The next element is 7. For 7, the previous node, this should point to 8. And the next element what we are inserting is 5. So for 5, the next pointer should point to 5 for 7, and for 5, the previous pointer for 5 should point to 7. Now we'll insert 6. So 5's next pointer should point to 6, and 6 previous pointer should point to 5. And for 6, the next pointer of the 6 should point to null. So this is nothing but an implementation of double linked list. Now, circular linked list. We understood in case of single linked list, the last node or the last element always points to null. But in case if in a single linked list, if the last element points to the first element, this becomes a circular linked list. Now that we have a basics of what a linked list is all about, let's see how we can represent this linked list programmatically. So linked list is a collection of nodes. So every node has two fields associated with it. One is for storing data and another one is storing the next element or the next pointer. So how we can represent the linked list programmatically? We can define an object which will have these two fields, right? So let's say we will define a class called node, and in the node, So the node will have two properties. Basically, we can define the data type what we want. Let's say integer data, and the next. So for this node, the next node should hold this object entirely, or the pointer, how we can define. So this is my next pointer. This is for single linked list. And let's look at the how we can define the double linked list. For double linked list, the node along with the data, it's gonna have a next pointer as well as it's going to have a previous pointer. So it's gonna have a next pointer and it's gonna have a previous pointer, right? So how we can define that? So we'll create the node object, and the node object is going to have the data. Then the node object will have a next pointer, and the node object will have a previous pointer. Okay. So this is the representation of a double linked list. In case of circular linked list, the single linked list representation would still work, but only the last element pointing to the null value should point to the first element. While implementing linked list, there is actually two approaches which we generally use quite frequently. Those approaches are either we can use the recursive approach to navigate through each element or to traverse through each element, or we can use the iterative approach as well. Another popular approach is the runner technique. So in runner technique, so instead of a single pointer, we actually take two pointers, and let's say in runner technique, let's say we have this set of data 8, 7 and 5 and 6. So I will take two pointers. So this is my, let's say, slow pointer, and another pointer would be fast pointer. So while I will move my slow pointer to a single step, so how I can move? Using the next pointer value. Okay. While I can move my slow pointer to a single value, sp.next, my first pointer, I will move it to two values. We will see using the runner technique, we will be able to solve few of the problems of linked list in an efficient way. So in our upcoming sessions, we'll look at basic operations on the linked list. So basic operation involve inserting a node at the beginning, inserting a node after a specific node, or inserting a node at the end of the linked list. This is true for deletion as well. We will look at those basic linked list operations. Then we will use the runner approach to solve few of the linked list problems. That is it for today. Please subscribe to support us and to get more updates on linked list and other data structures. Thank you. Thanks for watching.